Hey folks, let's get on to our last lesson in the exponent unit. Woohoo! So, what do I write here? 3, 2, 1, Terra! The date? When is this date going to be? I do believe it is March 17th, 2016. If there's anybody in the future watching this. Purpose 2.5 Exponent laws. Part 2. Alright, so the first one that I'm going to do here is what happens if I say 2 to the power of 3 to the power of 4? Oh boy. So as a repeated power, I know that 2 to the power of 3 is raised 4 times. So I would say 2 to the power of 3 times 2 to the power of 3 times 2 to the power of 3 times 2 to the power of 3. As repeated multiplication, whew, that's a lot of 2's. 1, 2, 3. Ah! I did what I said I would do. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. No, not 12, 2. So if I were to express that as a single power, I would say 2 to the power of 12. Think about it. What did I do to 3 and 4? You're right. I multiplied it. Okay, so whenever you have a power that's raised to a power, you multiply them. Let's try this one out. Negative 7 to the power of, and I'm doing this intentionally here, negative 7 squared to the power of 3. So I would stick out my negative here, and I go 7 squared times 7 squared times 7 squared. That is, now the negative hangs out in front, okay, because it's not in the bracket. 7 times 7 times 7 times 7 times 7 times 7. So I would get negative 7, okay, so negative 7 to the power of 6. Just like before, we multiplied these two numbers together. So why don't you take a moment and just create your own. You can pause it here if you want. And we're back! Before we lose it, let's flip over the page here and let's write the exponent law for a power to a power. When a power is raised to another power, or a higher power, multiply exponents. So, if I would say a to the power of b to the power of c, that just equals, as a single power, a to the power of b times c, where b and c are integers. Excellent. So let us go back to this page right here and talk about products of powers. Now I'm going to say quotient or, so let's change that. So if I were to say 2 times 3 to the power of 4, I would say 2 times 3 times 2 times 3 times 2 times 3 times 2 times 3. And what I want to do now is group all the 2's together. So I say 2 times 2 times 2 times 2 times 3 times 3 times 3 times 3. So if I were to go from this step to a product or quotient of powers. In this case, it's going to be product. It'll be 2 to the power of 4 times 3 to the power of 4. So we know that the exponent is distributed to the 2 and to the 3. What about fractions? You know what? I'm going to change that. It's going to be 2/7 to the power of 3. That means I would have 2 over 7 times 2 over 7 times 2 over 7. So as repeated multiplication here, it would just be 2 times 2 times 2 on the top and 7 times 7 times 7 on the bottom. So what would happen here is this would be 2 to the 3 over 7 to the 3. So this kind of follows the same logic as the powers. The power of 3 raises the 2 to the power of 3 and the 7 to the power of 3. So if you want to take a moment, create your own, maybe you want to put in a negative there. Interesting. The product law for power or quotient the product law for power of a product or quotient when a product or quotient is raised to a power, the exponent, or the product or numerator and denominator are all raised to that power. Example: A times B to the C means that it's A to the C times B to the C, or A over B to the C is A to the C over B to the C. Oh, and I shouldn't say that this is squared. This should be to the C, where C is an integer. Alright, you can pause it here, take as long as you want to write that out. Write each expression as a single power. So remember, we have one base and one exponent in a single power. So let's do A. So I would say negative 8 to the power of 5 times 4, which is negative 8 to the power of 20. Excellent. Now I'm noticing that it doesn't say and evaluate, so I'm doing a little bit of a happy dance, because literally that's all we need to do. We don't have to evaluate it. What about B? This one's a little bit more tricky because that negative out in front, but I'm going to say negative, and then the base is 5, and then it's squared to the power of 7, so 2 times 7, negative 5 to the power of 14, and we're done. Please note that this one is in brackets because the whole base is negative 8, whereas this one, the negative is out in front. Okay, it's not a part of the base. The base is simply 5. Now you can pause this and take as long as you want to write this down. Example number 2, evaluate. Now these numbers are going to get a little bit bigger, and there are actually different ways that we can solve it. So I'm just going to say method 1, method 2. And for B part, method 1 and method 2. What's really nice about this, folks, is that whatever method you feel more comfortable with, that's the one you use. So with this one, I can literally say 20 to the power of 2, because I'm doing what's in the brackets, okay, which is just 400. The other method I can say is, okay, so 4 squared times 5 squared, which is 16 times 25, which is the same thing, which is 400. It doesn't matter which method you use, because all I said was evaluate. Now this one right here, let's see if 168 is divisible by 14. Oh, and look at that. So if I do what's in the brackets first, 168 divided by 14 is 12 squared is 144. The other method that we could do is make it 168 squared divided by 14 squared. So that is 28,224 over 196. And guess what that turns into? 144. So it doesn't matter which method you use, whatever you feel more comfortable using. So as a summary, today we learned when we raise a power to a power, we multiply the exponents. Also, when we raise a product or quotient to a power, all factors or numerator and denominator are also raised. We should say are all raised instead of also. Sorry about that. To this power.